trust. If your teacher says that, don't tell him I said that. But the point is that, to me, there's various ways to get to the right answer. So whichever of these two methods feels more comfortable, makes more sense, is, quote, easier for you as a student, use that method. And if you were in my class, I'd say, I don't care how you do it, as long as the way you do it makes sense and you typically get the right answer. Okay. When we learned how to multiply back in 3rd grade, or maybe you were really bright and did it in 2nd grade, we looked at patterns. We saw that, for example, as you multiplied the numbers and got the 5 times table, all the numbers ended in 5 and 0, 5 and 0. Even in multiplications, let's see, 2, we had 2, 4, 6, 8, 0, 2, 4, 6, 8, 0. There were patterns involved. In polynomials, there are patterns involved too. Let's take a look at the next visual and see what kind of patterns we can see. And what I've done here is I have 5 binomial multiplication problems. Each one is a bit different than the one above it. For example, the first one, x plus 2 times x plus 3. Both numbers are positive. Okay? Then we have x minus 4 times x minus 1. Both numbers are negative. The next problem has x plus 5 times x minus 2. And one's positive, one's negative. The positive number is larger. And the last one of that type has x plus 4 times x minus 6. I said the last one, but I really wasn't lying. I was lying, of that type, because we have a positive 4 and a negative 6. The negative number is larger. And the very last problem at the bottom is x plus 4 times x minus 4, where one is positive, one is negative, and they're both the same number, 4. What I'd like you to do now is to stop the tape when I get through talking and multiply each of those 5 problems, come up with an answer, a polynomial. I'll give you a hint. It should have an x squared in it. You might want to check it using plugging in 10. And then I want you to also look at the answers and see what kind of pattern emerges in your mind, so that if you saw a problem, let's say instead of x plus 2 times x plus 3, you saw x plus 5 times x plus 9. Again, both numbers were positive. You'd have some idea as to what the answer should look like. So go ahead and stop the tape right now, do that work, look for the patterns, and turn me back on again, and I'll be in your face. Okay? All right, now, hopefully you did what I asked you to do. Otherwise, it's pretty silly because you just heard me stop talking and start talking again. The whole idea, as we said in Lesson 1, was to go and do the work. What you should have gotten are the answers that we'll see in the next visual. If any of your answers were wrong, I would suggest that you mark them wrong, go back, do them again, and stop the tape first, and see if you get them right. Do you see a pattern? Well, look at the differences. In the very first one, where both of the numbers, the plus 2 and the plus 3, were positive, you'll notice that we got a positive 5 and a positive 6, x squared plus 5x plus 6. On the other hand, where both numbers were negative, we got a negative 5x and a plus 4. Now, you'll notice, if you think back when we did the FOIL method, that when we multiplied positive 2 times positive 3 in that first problem, we are going to get a positive 6. And in the second one, we multiplied negative 4 times negative 1, we are going to get a positive 4. In other words, when we're multiplying binomials, we multiply a positive times a positive number, or a negative times a negative, we're always going to get a positive. And the only way we can get that constant term at the end of the answer is by multiplying a constant times a constant, or a number times a number. If there's an x involved in either of the terms we're multiplying, there's got to be at least an x or x squared in our answer. So therefore, we can see that when x plus a number times x plus a number, or x minus some number times x minus a number, the answer is going to have a positive number at the end. Look at the middle terms in those two problems. Why is the first one positive and the second one negative? Well, again, in our FOIL method, we multiplied x times 3 and 2 times x, which gave us 3x and 2x. We combined like terms and had 5x. In the second problem, we had x times -1 and -4 times x. We combined those and got -5x. When you're adding two positives, you get a positive answer. Adding two negatives, you got to get a negative answer. So, the x plus 2 times the x plus 3, that type of pattern says we're going to have a positive number in the middle term. The x term will have a positive coefficient with that number being the sum of the two numbers. That is 2 plus 3 is 5. In the second pattern, x minus 4 times x minus 1, we have -4 plus -1, giving us -5x. The next two patterns are different because we have opposite signs. When you multiply two numbers with opposite signs, you must get a negative. So therefore, in the third problem, we get -10 because 5 times -2 is -10. In the fourth problem, we get -24 because a positive 4 times a -6 is -24. But notice the middle term. To get the middle term in the x plus 5 times x minus 2, we multiply x times -2 to get -2x and positive 5 times x to get positive 5x, which means we have a -2x and a positive 5x, and adding two numbers, the -2 and the positive 5, with opposite signs, you take the sign of the larger and subtract, so we get a positive 3. Thus, the middle term in the answer is positive 3x. In the next problem, the x plus 4 times x minus 6, we add 4x and -6x, which gives us a -2x. So what you might say is the pattern in the third and fourth multiplication problems are that if you have x plus a number and x minus a number, the number at the end of your answer, the constant term, must be negative. And that if you multiply, for example, x plus 4 times x minus 6, again we saw it was negative. If the two numbers were multiplying, if the larger one is the positive, then the middle term will be positive. So we had the plus 5 and the -2, we got a positive 3x in the middle term. If the two numbers, the larger number was negative, like positive 4 and -6, when we added the positive 4x and the -6x, we got -2x. The last problem is interesting because the x plus 4 and x minus 4, we have 4 and -4, the same number, opposite signs. What happened? The plus 4 times x and the minus 4 times x canceled, and you should have wound up with x squared minus 16. Very special case if you're multiplying x plus something times x minus something, and the two numbers are the same, there'll be no middle term. There'll be no x term. You'll simply have x squared minus, if it's 3 and 3, 3 and -3, will be minus 9. If it's 7 and -7, it'll be x squared minus 49. In the time we have left, I'd like to go back and do a couple of more of these kind of problems. And again, follow along and try to figure out ahead of me what the answer should look like. For example, x plus 3 times x minus 7. Now, before we can start multiplying, and if you feel confident enough, go ahead and multiply, but I like to analyze it. What do I know? Opposite signs. Opposite signs means my number, when I answer I put over here, is going to be negative. And also I know I'm going to wind up subtracting, and since the -7 is bigger than the positive 3, the negative is the larger of the two numbers, my middle term is going to be negative. And again, using the FOIL method, x times x is x squared. X times -7 is -7x. Positive 3 times x is positive 3x. And positive 3 times -7 is -21. Not done yet because I always need to combine like terms. Same place value, I can combine them. X squared minus 7 plus 3 is -4, minus 4x. So again, my thinking was correct. Because I had opposite signs, that's going to be negative. Since the negative was the larger of the two numbers, my answer in the middle, my middle term is going to have a coefficient that's negative, and it's going to be the subtraction of those two numbers. Let's try one more. X minus 7 times x minus 3. Notice some similarity between these two problems. I stop for a moment. I look. Negative times a negative is going to give me a positive. They're both the same sign, so I'm going to add them. So my middle term is going to be negative. It's going to be obtained by adding. Let's go ahead and do it. X times x, x squared. X times negative 3, negative 3x. Negative 7 times x is negative 7x. Negative 7 times negative 3 is positive 21. Combining the like terms, I get x squared minus 10x plus 21. And again, because I multiplied two numbers with the same sign, negative times a negative, I got a positive. Since they both were negative, I wound up adding negative 7, negative 3, and got the negative 10x. Again, I stress to you, if you haven't been able to do these, go back, rewind the tape when the lesson is done, and try to work these problems out. As you can see in the lesson we've done today, polynomials are nothing more than whole numbers that have place values that are powers of x rather than powers of 10. We can check any arithmetic in our polynomials by plugging in x equals 10 and evaluating the problem. The rules for adding and for multiplying polynomials are identical to those for adding and multiplying whole numbers. If you can add and multiply whole numbers, you should have no problems with polynomials. And therefore, it's simply a matter of practice and recognizing what you already know. The problems can get more difficult or more complex, but ultimately, if you're multiplying, the rules are the same. If you're adding, the rules are the same. The key thing, and I can't stress this enough, is until you gain enough confidence that you know that you are right, check your problems by plugging in x equals 10 to ensure that your answer, when you plug in x equals 10 into your answer, is the same as the answer you get arithmetically when you plug x equals 10 into the original problem. The next lesson will deal with factoring, which is an extension of what we've done today. So if you can't multiply polynomials, you don't want to start lesson 3. Go back and be sure you can multiply. If you can multiply, then we'll be ready for lesson 3 next time.